Hi everyone, welcome to the chemistry presentation. I'm just gonna explain the drug response curve here. Concentration drug response curve that we learn in chemistry. It is basically the graph that describes the dose that, especially the medicines that we take in. So as you all can see, a dose response curve is the graphical representation of a dose responsive relationship, the magnitude of response of an organism from exposure to drugs and chemical interactions. Usually this graph actually demonstrates what kind of drug that we take in and what happens inside, especially it demonstrates the level of concentration, whether it is high or low, whether it reaches the maximum point or no. And the notes that I have under here is in a concentration response curve, the concentration of the drug is plotted against the percent maximal effect. So as you can see, I'm just going to go straight to explain the curve here. First, I'm going to talk about the x-axis. First, I'm going to talk about the x-axis, and then I'm going to go straight to the y-axis. Okay. The x-axis, which is the horizontal, it shows the concentration of dose of a drug from 0.1, 1.0, and up to 10.0. These are the maximum drug concentration, where it is like the level of high and low out of it. And the y-axis represents the response percentage. As you can see, it's the maximum effect in percentage it represents. Okay, I'm just gonna go straight to the main points. It's the maximum effect of the drug. This is a drug, so when a drug is taken, it starts from the concentration starts from 0.1. It goes all the way up, and this is where it reaches the maximum point. And this is where the drug concentration loses its energy or the strength it has to function in the body. This is when the drug loses its power, and that's when the doctor says you have to take the medicine again after every 6 hours, because the concentration is low and it already reaches 100%. So the bacteria might be active after it reaches the maximum effect of that drug. So I'm gonna go straight to I'm gonna show something on the graph here. It's basically I'm gonna show the difference between. Okay, this is the first drug that is taken. So the first drug that is being taken, the drug A, it's when the drug reaches 100%, it is known as full agonist. Full agonist is when the drug finishes the maximum effect, and it is 100%. The very reach 100% is full agonist. And the second drug that we take, it's the same, but it comes this way, comes up, and then it stops around here. It doesn't finish the maximum effect. So for this drug, we name this as partial agonist. Partial agonist because it doesn't complete the 100% maximum effect of that drug. This is because due to some properties of the drug, or some kind of things that are inside the human body that distracts the whole concentration of the drug to take place. Okay. The other thing that I want to stress about the drug is that along this path there's on this curve, the point or the peak is called ECO5. This ECO5 is the concentration. ECO5 is basically the response it is basically 50% of 100% concentration that has been used by the body, So yeah, basically this graph usually shows the amount or the job or the function of effect that the drug has on our body. So sometimes, due to fats and stuff like that, it drags the concentration. This is where it doesn't reach the maximum or the maximum effect, which is full agonist. We all know what agonist and agonists are. So this is where it reaches the maximum effect and partial agonist. So this brings us to the end of our presentation, and thank you for watching.
What is the term used to describe the minimum effective concentration of a drug? Correct answer, potency. Potency refers to the concentration of a drug required to produce a given effect. A drug with high potency requires a smaller concentration to achieve a desired response.